Okay, now I'm going to show you how to construct a data flow diagram. And the data flow diagram is the second modeling tool that we would use, and it's built upon what we've constructed already with the IPO diagram. So firstly, before you construct a data flow diagram, it's really important that you understand the four main types of symbols and their purpose. So the first symbol that we have here is the rectangle, and the rectangle is an external entity. Now the external entity is generally the user or a person or process that interacts from outside with the system. They're normally in the form of a rectangle. The second is a process, and that is in the circle, and they would be identified within your IPO diagram. So I identified two processes, so within my data flow I'd also have two processes. The third symbol is your data structure. Now, like with the processes in a data flow diagram are generally a bit ambiguous. They're a bit of a black box. You don't know exactly how they work. And the same with your data structure. You don't actually know what type of data structure you're going to use, whether it's going to be an array of records or a files. But it's just putting it there, modeling it, making sure that the developer themselves knows how everything interacts. The final element of the data flow diagram is your flow lines, and your flow lines will show that actual flow of the raw data within the software solution. So they could be variables or constants, so index, temp, and it shows how they actually flow within the process. So data flow diagram must have those four main aspects for it to be an appropriate data flow diagram. So we're going to construct one for our iPhone app here. So the first thing I do when I construct data flow diagrams is to generally draw up start with the external entity. So the main external entity for this software solution is the user. And if we come back to the purpose of this app, the user is going to enter a range of raw data that is then going to be calculated to output the biological age test, which along with the user's name, the biological age will be stored in an appropriate data structure. So we know that the first process that we want to have a look at or generate here is the calculation. So we know that it wants to calculate the biological age. And once that calculation has taken place, it's going to display via an output back to the user that information, which is the biological age. However, in order to be able to calculate the biological age, we require some inputs from the user first. And these are called raw data because by themselves they're just raw, there's no meaning to them. However, when you put them together, they perform or provide us with the basis of making this calculation. They were identified in an IPO diagram, and they were age, weight, height, BMI, was also body fat index, body fat percentage, and blood pressure. So they are all variables that would be sent from the user to that process. Now, the next thing or our second process that we have within this software solution is the storage. So we want to store our user record. And once again, our processes are black boxes. We don't really know actually how they're going to work, but we need to model them and outline so we know exactly how the system's going to relate to all its main elements. So in order for us to store the user's biological age, we need biological age. So that needs to come from that process, and biological age is sent. The second thing we also need, which we outlined in an IPO diagram, is we need to come from the user, we need their name. Okay, now this is all showing the flow of data that exists. Now a final thing that we need to do is we need to take name and biological age and send that to our data structure. And we need to write name, comma, biological age. So a couple of pointers with a data flow diagram. It's very, very important that you don't change the name of your variables. So I could have got a bit lazy there at the end and write bio age. Now I would have lost marks for that in an exam. So finally, when we're looking at the data flow diagram, there's some important aspects that you need to show, especially with biological age. You're showing the flow that it's something that's been calculated from this raw data. This process has taken place. Biological age is sent back to the user. It's also taken from there to this process that stores it, which is then sent to the data structure. At no time is anyone who's viewing this data flow diagram at all confused where biological age has come from. The same with name. We can see the flow of where name has actually come from, and all of these have come from the user. And that's the main purpose of the data flow diagram. Obviously, these can get a lot more complex in their nature, but as long as they reflect what you've outlined in your IPO diagram, that if you've got 4 processes in your IPO, you have 4 processes within your data flow diagram, and also the fact that you remember that at this moment it is still a black box. You don't know exactly how you're going to calculate the biological age. You don't know what data structure, but this is the process of planning and modeling which is required in software development.